Hello, beautiful people, and welcome. In this video, we are going through the second practice test for your Chapter 2 examination in Integrated Math 3. Before we do any questions, I do want to mention that I am human, so if I make a mistake, that's okay. Just let me know where the mistake occurs so that way I may fix it and learn from it. All right, the objective of why I'm making this video is just to show you what I am expecting of your work and your answers in our upcoming test. So the first question we have here is given the function f of x is equal to the absolute value of 2x minus 5, write a function g of x that reflects across the y-axis, so there's going to be some transformations, reflects across the y-axis, that's important, stretches f of x vertically by a factor of 3, and then translate the function up 1. So there's a few ways of doing this. I think yesterday or the day before in my class, if you're watching this video a little later, then not then, we started doing our little tables to just help us sort out what happens first, second, third, fourth. So the first thing we're going to do is we're going to reflect across the y-axis. We are then going to stretch vertically by a factor of 3, and then we're going to translate up 1. So there are 3 changes, there's 3 translations that happen. When you work with these, I'm going to write f of x. Now, f of x is equal to the absolute value of 2x minus 5. We're going to ignore that for a few moments. When you write f of x, the y being transformed or reflected means that you're going to have a negative on the inside of the function. So when we have the absolute value of 2x minus 5, that means that I am going to take the original x, and I'll highlight that for you. This is our original x. This will be our original x. But since there has been a transformation, we're going to take this new inside and replace the original x with it. So instead of writing 2x, I'm writing 2 parentheses negative x. Yes, the parentheses are important. So that means I have absolute value of, simplify this, negative 2x minus 5. Now I am giving this a name. This is now f of x. But wait, we have an f of x. Yes, I know. This f of x, this original f of x, no longer exists. We have done something to it. What did we do to it? We reflected across the y-axis. So now this is my new f of x. So when I go to stretch vertically by 3 and I write f of x, this is the f of x that I'm writing as absolute value of negative 2x minus 5. To stretch vertically by 3, that happens on the outside of the function. So when I write my function, I am going to be writing it on the outside with parentheses. Now, there is an absolute value here and there is parentheses. Now, I'm being a little extra with the parentheses because we are multiplying f of x by 3. That's our transformation. We are stretching it vertically by 3. So that means that if there was something not inside the absolute value, we would have to distribute. Now, if we take a look at what we have, there's nothing for us to do here. This is the new f of x. And again, if there was something to do there, we would distribute, but we cannot go inside the absolute value because we are not doing anything to the inside of the function. We're going to take our new f of x, just copying it down. And now again, what are we doing to that f of x? We are shifting it up 1. That is a vertical change. So that means that we are taking our new f of x. Oops, that should be a 2. So here's my f of x, and then I'm adding 1 to it on the outside of the function. Again, if there was something to simplify, we would simplify. Because of the way this function is, there is nothing to simplify. We would simply write it. Notice this is my last transformation. There's nothing for me to do after this. So we can write this as our answer. Now there is one step further that we can go. I did box this. So this is an acceptable answer. There's nothing wrong with it. But we can simplify this a little bit more and pull out that negative 1 from absolute value from the 2x and negative 5. The absolute value of negative 1 is 1. And we can simplify it one more time. If you don't do this on your exam, that is okay. But if we can simplify, we should simplify. This is an acceptable answer. This is a much better answer. Moving on. Given the function f of x is equal to 3x minus 4, write a function g of x that reflects across the x-axis, so a little bit different, shrinks horizontally by 1/2, and write 1. Again, you can do t-chart or you can go just straight in. I'll do the table here. So we have a reflection across the x-axis. We have a shrink by 1/2, horizontally, that matters, and a right 1. So here's our f of x. So what happens to it? We have a reflection across the x-axis. X-axis means on the outside. Our function is 3x minus 4. So when I write my function, because it is on the outside, 3x minus 4 goes inside parentheses, and that negative goes on the outside. That means that I must distribute my negative. So my new f of x is equal to negative 3x plus 4. When I copy it down here, that is my new function. The original no longer exists. Now we have a shrink horizontally, which is inside, by 1/2. Now remember, if it's horizontal, you either take the reciprocal or you change the sign. If it's a shrink or a stretch, you take the reciprocal. If it's a shift left or right, we do opposite of what we see. So shrink of 1/2 means I write 2x. This is inside my function, so I am taking negative 3x plus 4, and I am replacing that x with 2x. Yes, parentheses are important. So that means we have a new function f of x is equal to, simplify, negative 6x plus 4. Taking that function to my last step, or my last change, and we have a right 1. Right means horizontal. That also means opposite of what you see. So instead of writing a plus 1, we're going to write a minus 1. This is again inside the function. So that means instead of writing x, I'm going to be replacing x with x minus 1. What happens here is you will need to distribute. This is a pretty decent change. So I'm going to be distributing that negative 6. Glad I have some extra space. Negative 6x plus 6 plus 4. Distribute only on the inside. Don't touch this plus 4. Then we have negative 6 plus 6, 7, 8, 9, 10 as our g of x. Again, beautiful people, if I am going a little bit too quickly for you, this is a video. Feel free to pause, rewind, do anything you need to do, take a break, go get some coffee, and then come back. All right, we got one more. Given the function, the absolute value of x, if g of x is equal to negative 2 times the negative 1/2 x plus 1 absolute value minus 3, describe the transformations. Okay, so that's a lot to say. What this is just saying is describe the transformations. Describe the transformations means write this in English. So you're not actually doing anything like question 1 or 2. You're just describing. The way I like to do it is I like to circle. So that means negative gets a description, 2 gets a description, negative 3 gets a description, and then anything here needs to be factored out, but still stay in the function. So when we are factoring out that negative 1/2, we'll talk about the negative and the 1/2 in a bit. Inside the absolute value, we still have this. Here's a little thinking bubble. Some of you are correlating the factoring with division, and that's okay. There's nothing wrong with that. But what ends up happening is what I'm seeing is whatever you're factoring out kind of just disappears. It just goes poof, gone. doesn't happen unless you are quote unquote canceling stuff out, or you are dividing to 1 or multiplying to 1. Things don't just disappear. You have to have order of operations. You have to have things with 0 pairs. You have to have things dividing, multiplying. So don't let your b value just go poof. If you're removing it, if you're dividing it out, it stays. This b that you see in your original and this b that you factor out has to be the same, and it has to still remain. Ha, that rhymed. Okay. So, with the division, if you are typing this into the calculator, you must have your fraction in parentheses. And when you remove that 1/2, it stays. Had my little rant a few seconds ago. So that means that if you have fractions, -1/2 divided by -1/2 needs to be in parentheses. That's just 1. So that means we have 1x. And here I have 1 divided by -1/2. You can see it better. And that gives me a -2. So that means in here we have x minus 2. So now I need to describe this inside negative. I need to describe this 1/2, and I need to describe this -2. So there are 1, 2, 3, 4, 5, 6 arrows that will need a description. Let's start from left, work our way to the right. We have a reflection across the x-axis. We have a vertical stretch, and I'm okay if you start abbreviating. I would understand the difference between a VS and an HS. But the vertical versus horizontal is very important. Vertical stretch by 2. I have a reflect across the y-axis. I have a horizontal, remember, take the reciprocal, so that means stretch by reciprocal, 2. Opposite of what we see, so right 2 and down 3. If you want to list this like a paragraph, that's fine. I prefer arrows because that helps me make sure I don't miss any number or negative. Let's graph here. Graph the function f of x is equal to 2 times x minus 1 squared plus 3 on the coordinate grid. What is the domain and range of the function? Use at least 5 points. Make sure all points are clearly indicated. This is a vertex form. So we have, there's some space down below. So we have f of x is equal to 2 times x minus 1 squared plus 3. First thing you have to ask yourself, is there a b value? Do I need to factor? Since technically it's 1, but since there's no b, no factoring. So you don't need to factor like we did in number 3. That means this is your h, this is your k for your vertex. Opposite of what you see, h. Keep k, so k for keep. That means your axis of symmetry, and you do need to know this on the graph and to list it out, this is 1. So immediately I can go towards 1. Let me highlight this here. If you want to bring colors on the assessment, bring colors for the assessment. It's easier for me to grade that way anyways. Then we have our first point at 1 and 3. 1, 2, 3. Now it is asking for 5 points, so I am going to make a quick little t-chart and plug in my vertex and then choose one direction to go. You want to go up? Great. You want to go down? Great. So I'm going to do 2, 3, 4. When typing this into the calculator, make sure that you type this into the original. So if you needed to factor, get your vertex h and k and then go back to the original. What number am I typing in? 2. Minus 1. Close it, square it, plus 3, and I get 5. Again, go up, go over, and now my number is 3, and I get 11. It is asking for 5 points. So if you find 3, you can reflect them. So I have 1, 3 already. I have 2, 1, 2, 3, 4, 5. Reflect that over. 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, almost didn't make it. So it's somewhere here and reflect that. 3 jumps, 1, hold on a second. 2 jumps from the axis of symmetry, 1, 2 jumps from the axis of symmetry, so we're about here ish, right? Curve, please do not give me anything with sharp edges, otherwise that's an absolute value and it will be marked wrong. Domain is always going to be the same, so there's really nothing to think about for domain. It's always going to be negative infinity to positive infinity. You can also write all real numbers. If you want to use set notation, interval notation, English, that's fine. If you want to write all real numbers, that's okay as well. Now, domain talks about the possible x values. So these are your values on the x-axis. Now for range, this talks about your y values. For a quadratic, this is what we're doing. For a quadratic, there is a limitation on your y values. You will either see a minimum or a maximum. In our case, we have a minimum value. That's going to be the smallest amount. And we want to go small on the left side and large on the right-hand side, just like on a number line. So that means that our smallest number that it can be is 1, 2, 3. And we go all the way up to a positive infinity. Now, infinities get parentheses because it's a concept. We cannot grab infinity. But because it can be 3 on the y-axis, it gets arms in our bracket. So think of like reaching in and grabbing someone. That means you extend your arms and pull them in like a hug. And so these are your arms to grab 3 and pull it in. Okay, let's move on. Okay, I am looking at the time and we are 16 minutes in. I am going to try to go faster. Again, at any point I'm going too fast, pause it, rewind it, and rewatch. Otherwise, we're going to be here for hours. All right, intercept form. You got your P, got your Q. Step number 1, you're going to do opposite of what you see. So negative 2, 0. Positive 4, 0. That means for your axis of symmetry, you're going to take these numbers. So one of the hiccups that I see is that you are taking the opposite and then taking the opposite again. Don't do that. Just do it once. If you're typing this into the calculator, make sure you have this in parentheses. Otherwise, your calculator will lie to you and it only will divide 4 and it won't actually add the negative 2 plus 4 together. I get a 1. So that means axis of symmetry is x equals 1. Take that 1, you're going to plug it back into the original equation. You're going to type this into the calculator, which will help with your next step as well. Now, don't let that negative fool you or trick you into thinking it has anything to do with anything. It does. It tells you if it's going to be an increasing or decreasing, but you don't actually have to do anything with it. I'm trying to show you that I do have a negative right here. Negative. Type it in, enter, I get 9. So that means y is 9. So my vertex is 1, 9. Take your vertex, plug it into your t-chart. Again, choose a direction. I'm going to go 2, 3, 4. Go up, go over. Instead of 1, I'm typing in 2. And I get 8. Go up, go over, type in 3. And I get 5. Go up, go over. These are nice numbers, so I'll do one more. And 0. Start out with your axis of symmetry. Our axis of symmetry is at 1. We know this is going to be a decreasing function pointing downwards because of that a value. We have a 1, 9, 5, 6, 7, 8, 9. Ooh, cutting it close there. We have a 2 and 8, 2, 3, hold on, 1, 2, 3, 4, 5, 6, 7, 8. Reflect that point over. And we have a 3 and 5. 0, 1, 2, 3, and 5. 2 jumps from your axis of symmetry. We are asking for 5 points. Curve, point down, and you're done. And it is asking for x-intercepts. So we already have our x-intercepts right here at negative 2, here, and at 4. So although I have my arrows, it is asking you to identify your, so I'm going to change my curve here, your x-intercept. So we got to extend it past our x-intercept, so be careful. These must be required because it is on the intercept form. I'll give you a moment to take a look at that. Pause the video if you need to stare at it a little bit more. Moving on. This is your standard form. Circle your A, B's, and C's with the symbol. For your axis of symmetry, we have our formula of negative b over 2a. If you are choosing to use calculators, then your a and your 2 needs to be in double parentheses. Negative b is a positive 1. 2a, a is 1/4. And I am going to use a calculator on that, so I don't have to use too much brain power. So negative parentheses 1 divided by 2, 1/4. Close it. Again, oh, you guys can't see that, sorry. This needs to be in double parentheses or double bubble. And I get negative 2. Very happy with that value as it is pretty. Take that value, plug it into the calculator, and this is where I'm going to stress parentheses. Otherwise, things can get messy with your negative. And I'm going to stress that you make sure that your fraction is in parentheses as well. Fractions must be in parentheses unless you have a fancy calculator that does the fraction correctly. Ours, the one that we have in class, do not. So you need this in parentheses. Negative 2 squared plus negative 2 minus 6. And I get a negative 7. So that means our vertex is at negative 2, comma, negative 7. So negative 2, where's negative 2? 1, 2. 2 and negative 5, 6, 7. Vertex here. And here's the good thing about having typed that in to solve for your y. We can start off with our vertex and then choose one direction. You can either go up or down. I'm going to go at negative 3, negative 4, negative 5. I already have all of this typed in, so I'm going to go to negative 2 and put in a negative 3. And I get negative 6.75. And I'm going to cross that out because it's not a pretty number. I'm going to try negative 4. It is much better. So notice here that it's not asking you for 5 points. There's a reason for that. So we're just going to use these and then reflect over. So we have our vertex at negative 2 and negative 7. Then I have negative 4 and negative 6. 2 jumps, 2 jumps. Curve, curve. I don't have to make this super extended. State the vertex, write that in. It was negative 2, comma, negative 7. Is the vertex a minimum or a maximum? This right here is the smallest. So we want to circle. Axis of symmetry on the graph. Y-intercept on the graph. So here's your y-intercept. Crosses the y-axis. And identify the domain and range. Domain is your all real numbers. Again, that doesn't change. But here, for your range, what's the smallest that it can be? It can be a negative 7. What's the largest it can be? Well, we're going all the way up to positive infinity with a parentheses. Now, I do want to mention for the y-intercept, sometimes it's not always clear. It doesn't always happen to reflect over and get you on the y-axis. This is where you set x equals 0 and solve for y. And you can do this for all functions. So we got y equals 1/4 0 squared plus 0 minus 6, and that will get you your y-intercept. Right, moving on. Okay, we have systems here with 3 variables. Step number 1 is you're going to choose 2 of them. I always go for the top 2. And you're going to select a variable to eliminate. So for me, I'm already looking at the z's. One of them is negative. Actually, both of them are negative, so I'm going to multiply the top one by a -1. You don't have to do that. You can just subtract, but I'm going to do that just to make my life perhaps easier, but now I don't have space, so perhaps that's going to be challenging. It's okay. So I'm going to make it work. -4x minus 3y plus 3z is equal to -9. Nope, that's going to bother me. I'm going to write this here. So -4x minus 3y plus 3z is equal to -9. Oh, you guys got a little too comfortable here with writing on the side. And then this one is going to be 6x minus 4y minus 3z is equal to -22. And this should have been a positive. Trying to make sure that I flip the sign. So opposite, 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 opposite. Okay, so now we're going to add. Make sure that you put these pluses here. What I'm noticing, you guys are making hiccups because you are not putting the pluses and you're just letting your brain make assumptions. Don't make assumptions. -4 plus 6, that is 2 x's. This is -7 y's. This is gone. And we got 9 minus 22, which is -13. I'm going to put that in a thinking bubble. This is our temporary equation here. Now you have to take the third one. Now this one already has 2, but notice here that we eliminated z, so that means I must eliminate z here. We don't even have a y. So instead of writing my equation the way that I did, I'm going to put a placeholder for y. The same thing, just 0 for y. Why did we do that? Because we have no y's. I do need to eliminate the z, so I am going to choose, what am I going to choose? Top or bottom? It doesn't matter. Let's do the top one. Let's do 4x plus 3y minus 3z is equal to -22. That means I'm going to need to multiply top and bottom to get rid of my z's. I'm multiplying this by +3, and I'm multiplying this by -2, just because I need those signs to be opposite. You're going to multiply every single thing on both. -6x plus 0y's minus 6z is equal to 18. Here we have a -8x minus 6y plus 6z is equal to +44. Again, add. So we have -6 plus -8, which is a -14x. Here we have a -6y. Z's are gone. 18 plus 44. Oops, 18 plus 44 is 62. Now, a question came up earlier, I guess not earlier, but in previous days. Should we simplify these? If you can, go for it. So maybe you can divide every single thing by 2. So we would get -7x minus 3y is equal to 31. You can do that, but you don't have to. So if you simplify, it's okay to simplify. You don't have to, but if you are simplifying, please don't set these equal to each other. If you simplify, then this equation's gone. So then you're going to set these equal to each other. For a quick second, I got excited about those 7's, but those 7's are kind of not going to help me because I have 2x minus 7y is equal to -13 minus 7x minus 3y is equal to 31. So definitely didn't help me, but I did. Get me excited for just a second here. All right, so do we want to get rid of the x's or do we want to get rid of the y's? These are already opposite, so I'll get rid of the x's. So I'm going to multiply top by 7, bottom by 2. A little disappointed that it didn't just magically work out. 9y is equal to -13 times 7 is 91. And then we have -14x minus 6y is equal to 62. Adding, adding, adding. Yeah, get rid of it. Negative 49 plus negative 6. That's negative 55. Y, we got negative 91 plus 62. And I really don't like that answer. Because if we continue dividing, that means something went wrong. Let's pause and reconvene. And we're back, beautiful people. I did take a quick little mini break to just stare at this. I didn't want you to sit there with me having to stare at it. And for the life of me, I could not find where I made a mistake. Now, it doesn't mean that the answer can't be a fraction. I just know that it's not going to be a fraction. So if you caught my mistake earlier, so everything was fine. So I'm going to erase here, and I just want to show you that it's okay to make mistakes. But if your answer seems off, you can just ask me on the test, and I can tell you yes or no. I'm okay saying that. If you're like, is it supposed to be this icky? But I did find my mistake when I actually copied down here. If you saw this mistake and you were screaming at the video, I applaud you. Thank you. If you didn't, you're on the same boat with me. Let's fix it. So 4x plus 3y minus 3z is equal to a negative 9. I accidentally took the bottom one. So this should have been, so this is going to change a few things for us. Not a lot, so I didn't want to restart it, but I did bring out that large eraser. And it's okay, we're human, right? Humans make mistakes, we're human. It's good to be human. So when we're here, we got, why am I doing that? We got a positive 18. And so that means 18 plus 18 is 36. And when I divided that by 2, I got an 18 here. So this right here, this negative 9, was my original mistake. I accidentally took the negative 22 from the wrong equation. So let's go ahead and try this one more time and see if it can get us a prettier answer. Once again, traumatized by that 7 because I thought it was going to work. It didn't. So I still need to multiply everything here by a 7 and everything here by a 2. So that means we got 14x minus 49y is equal to, and I already forgot what that was, negative 13 times 7, which is a negative 91. And then we got a negative 14x minus 6y is equal to 18 times 2, which is 36. Fingers crossed this works this time. We're adding, adding, and adding. 49, negative 49, minus 6, that's negative 55, y, negative 91, plus 36, and I'm very happy and honestly very relieved to see that negative 55 divided by negative 55 divided by negative 55, y is equal to 1. Very much better. Okay, so now that you have one of your variables, you're going to take it and plug it into one of these equations. Now you can choose the simplified, unsimplified. I'm going to choose this one just because I have space. No other reason than that. Y was 1. So we have negative 7 is equal to negative 13. Add 7, 2x, negative 13 plus 7. And I get a negative 6, so that means x is equal to a negative 3. Okay, so now you have a choice to make, and this is very unique to this question. You can either choose one of the 3 variable systems, or you can choose, actually, you can't choose the third one. We're trying to, no, can we? We can. We're trying to solve for z. That's the only one left. So I can choose one with 3 variables, plug in 1 and negative 3 for x and y. Or I can choose the third one, which doesn't have a y, and just plug in x. That part doesn't matter, but I'm going to choose a 3 variable one just because that's going to be what you will do most times. This third one is unique to this question. So we got -3 for x, 1 for y, and we're solving for z. Make sure I copied it down correctly. We got -12 plus 3 minus 3z. I'm going to add 12, subtract 3. That's gone, that's gone. We get -3z, trying to make it fit in here, skipping a little steps. I get 0. Divide by -3, divide by -3. So z is equal to 0. Okay, let's actually write out our answers pretty in the box. X, Y, Z. We got there, beautiful people. Had to take a quick little mini detour down the wrong path, but we got back to it. All right, let's go ahead and do question number 8. Very similar steps. Take the first two. Choose one of the variables to eliminate. Do I want the first two? I'm actually looking at the bottom two right now. Not that it matters, I can do the next one. It's okay, let's just keep it. If you want to do the bottom two first, you can. You definitely have my blessing on that. Choose a variable to eliminate. I'm going to think ahead and I'm going to eliminate x's in my other one. So I'm going to multiply this by a -5. So we got -5x plus 25y minus 25z is equal to 28 times -5, which gives me a -140. Bring down the bottom one, 5x minus 3y plus 3z is equal to 30. We're going to add, eliminate that x. That's gone. We have 25 and -3, which is 22. We have -25 plus 3, which is -22. And -140 plus 30, which gives me -110. Same thing as before, you can choose to simplify this if you wanted to divide by, actually, does 110 and 11, that's good. I'm going to divide by, hold on. I'm really thinking if we can divide everything by 22. So if you want to stay with this one, you can, or you can simplify just to make your numbers smaller. So I'm going to simplify by dividing everything by 22. I tried 2, I tried 10, both of them worked, or 11, not 10, 11, and turns out 22 can go it. So we got 1y minus 1z is equal to, and what was that? -5. All right, now I'm going to go back to the other bottom two, and I'm going to eliminate my x's that I originally chose to eliminate. One of them has to be negative, so I'm going to switch my symbols. I'm going to multiply here by negative, just by changing the signs. We're going to add. So that happened kind of quickly. When I multiplied the bottom one by -1, I kind of didn't show you what I did. It's just changing the sign on every single term in that bottom one, which that's multiplying by -1. So x's are gone. We have -3 plus 2, that's -y. Then we have positive z. And 30 minus 25 is 5. Ooh, look at this. Pretty cool. We got y minus z is equal to -5. -y plus z is equal to 5. And we already know what's going to happen when we add all of these together. This will give me a always true. Now remember, always true doesn't mean that's your answer. That means you have a dependent answer. This is like saying it's going to rain today. Okay, but show me proof, right? So we want to have a dependent answer. So you can either solve for y or you can solve for z. If you solve for y by adding z to both sides, that means y is now dependent on z. If you were to solve for z, then z would be dependent on y. But y is dependent on z. So then we're going to take one of our originals. So I'm going to separate this out. Circle that. We have x minus 5y plus 5z is equal to 28. X we need to solve for. Y we know is dependent on z, and because it is dependent on z, z stays. We don't mess with z because we are dependent on it. Distribute that 5. Notice what happens. Z's go away. Doesn't always happen that way. Sometimes it happens that way where you're left with just x. But x can also be dependent on z. There's nothing wrong with that. Subtract 25. I think we're getting a value for x. 28 minus 25. I used a calculator for that. That's silly. And we have that x is 3. Okay, so how do we write our answer? To write our answer, we're going to say x was 3, y was dependent on z, so z has to be left alone. All right, beautiful people, I know this is a longer video. Lots of information to go through, but we're almost done. We're on the back side. Just a little bit longer. I feel it too. All right, write a function in the form f of x. Hold on. Let's try this again. Try to hurry up and making tongue twister. Write a function of the form f of x below in the vertex form. Okay, so it wants f of x, so immediately write f of x as part of your answer. It does want an equation, so there has to be an equal sign, and they do want f of x. They want it in vertex form, so vertex is h comma k, x and y on the point. When you write in your x and y, don't mess with them. However, when you write in your h, it's opposite of what you see. So notice how I had a -5, but I'm writing a +5 here. K is for keep, so we keep it at -2. Order of operations, please make sure you do respect your Aunt Sally. Parentheses, then exponent, then multiplication division, then adding subtracting. So that means -7 plus 5 is first. Then we are squaring it. Use a calculator. Oh, I want to show you this. So something that I'm seeing, you guys are doing this, -2 squared. This is wrong. This is not correct. Remember, your calculator will lie to you if you don't type in the correct stuff. It's in parentheses. It must be in parentheses, so when you square it, it will give you the correct answer. If you don't put in the parentheses, it will lie to you. This step is very important. Rearrange it as 4a minus 2. Do not combine the 4 and the 2. They don't belong together. The 4 belongs to the a. Add 2, add 2. Divide by 4. Simplify. So a is 1/2. So that means that we have, actually I don't need an arrow here because we're going to write our answer already in the answer spot. So we have 1/2 times x, opposite, so +5 squared, and -2 as our answer. 3 more, and we're almost done. Write a function in the form f of x in intercept form. Okay, so you're going to take your intercepts, 3, 0, and 7, 0. That means when you have your format, you're going to do opposite of what you see. So +3 becomes a -3, a +7 becomes a -7. Then you're going to take your point, this is your x and y. Y was -4, x was 1, and x was 1. I'm running out of space. You can do this by hand. I actually don't recommend you do it by hand. I just say type it into the calculator. On the test, sometimes you're short on time. So just type it in. Ignore the a, press enter. So that means we have 12a. I'm going to divide by 12, running out of space. So that means, oh, I want to show you this. I learned that this year. So we have -4, ABC, 12, and that will simplify your fractions for you. So we have a -1/3 for a. We had our intercept at 3, so I'm writing at -3. And we had an intercept at 7, so I'm writing a -7 for our answer. Last two, write the following equations in standard form. We have an intercept, we have a vertex. Kind of what you do is similar, except this one for intercept form, you don't need to expand. We got x times x is x squared. X times -2 is -2x. I'm going to keep that in parentheses. 4 times x is 4x. 4 times -2 is -8. Simplify that and distribute your 1/2. And you have your function. You can keep it as y, you can write it as f of x, your call. I'm going to go through this one more time. That happened kind of quickly. Step number 1, we need to distribute. Then we need to combine like terms. And then we distribute it again. Here, very important, so I'm going to slow down on this one. Whenever you have something squared, a bubble squared, it's very important to recall that this is not bringing the exponent on the inside. We can't do that. What that means is that you are writing the inside of the parentheses twice. So I don't have x squared minus 16. That would be weird. That's a big no-no. What I do have is x minus 4 times x minus 4. Now here I distributed using arrows. I'm going to show you a box method. Depending on where your mathematical background is, sometimes instructors use a box method, like a multiplications table. X times x is x squared. X times -4 is -4x. -4x here, and a positive 16. This needs to be combined as like terms, so we got -2 parentheses x squared minus 8x plus 16, and we got our -1 on the outside. Do not combine these for any reason. Instead, you have to use order of operations, which means you have to do your multiplication distribution first at -2x squared plus 16x minus 32. Then you can do your -1. -2x squared plus 16x minus 33 is your y, or you can write it as f of x. All right, beautiful people, that is it. Thank you if you stayed towards the end, I appreciate your time more than you know. If there are any mistakes, let me know so I may fix them. Other than that, go ahead and enjoy the rest of your day. Take a deep breath. You've made it. And I will see you next time in the video or in class for our actual examination.